the major pathologies that we have identified. This is almost unchanged from it's almost a year ago where we met, but we still have very similar problems, but we're progressing, and that's very nice. But I can still show you the same problems that we had a few months or a year ago, which is we have instant multisig upgrades. So we have an epidemic of multisigs that are not professional. So that are random project-owned multisigs with low thresholds, many members, and sometimes even externally owned addresses, so single addresses that can upgrade a project. This is an epidemic because it affects lots of projects.
When we say multisig, and okay, many people signing a transaction in order to move the funds, for instance, that's one type of multisig. Another multisig is saying, hey, we have a smart contract on Ethereum and we want to upgrade this smart contract, and there are like 5 people that need to sign to update it. What do you mean in this like layer 2 case?
Yes, this is a good question, and I have an answer handy. For example, this is now an on-chain view. This is a smart contract, the thing I've selected now, and this smart contract is a multisig. I also named it turnkey multisig because it's owned by turnkey, but that doesn't really matter. A multisig is roughly defined as a threshold contract for multiple signers. So if you have these 5 addresses that are also on-chain addresses, you can see the values even, and these 5 addresses can then be registered in a different in a contract, which is a multisig, and this contract has a threshold. So this is a very bad threshold. It's nice for illustrative purposes because I've apparently grabbed like the worst multisig, which is a 1 out of 5. So this basically means that any one out of these 5 addresses can act as this contract. So this contract can then be further registered, for example, as a nested multisig. It's complicated. So this contract is now a member of a different multisig, but this multisig could also be registered as an executor, as an admin in a different contract. We can go one further. This is a security council. So this is a very good multisig. It should have, I think, 8 members. And this security council contract, for example, can only act if 6 out of any of the 8 members agree and sign a transaction. And then the security council has like named participants. One participant is another multisig. This security council, for example, is an executor in a different smart contract, which then can upgrade the entire contract system of the rollup of the layer 2 solution. So it can, for example, upgrade the bridge, which holds all funds. So this could, for example, they could steal all funds. And upgrading means like upgrading is an euphemism because upgrading just means changing the smart contract code, which in the stage 2 rollup should basically never be done at all or with very long delays, right? You should not change the rules of the game.
Paulo, you have a question.
You showed 2 examples of multisig contracts. One that was good one that was bad. The bad one is because anyone can change something, so you only need one participant if he has full access. The good one was that you had higher. My question is, what is the criteria for a good one, bad one? Why not go to require unanimity rather than 75% or any percentage? Because there are trade-offs. What are the trade-offs and what is the function that you have in mind to judge that, okay, this is a good trade-off, this is a bad trade-off in this circumstance?
There's so much to that, but to keep it very simple, at L2Beat, we only consider 2 types of multisigs. One type is a very clearly defined type, which is the security council. And for security councils, we have very many requirements. Like we have very specific threshold requirements. We have very specific member requirements. They need to be public, external to the organization. They need to have a member count. They need to have a certain threshold, which is dependent on the member count and all these things. And for all other multisigs, we consider them basically one group. Let's say we want to categorize this multisig. Let's say it has a 5 threshold, so 5 out of 5. But we don't know who these are, these signers. So they could all be the same person. This doesn't help us anything. If we say, okay, you require unanimity, it doesn't mean anything as we don't know who this is. And then what do we do as LTB? Do we require an attorney statement that the address is owned by this person? Like, how do we, you never know on the internet that someone is a dog, right? You don't know if they are actually who they pretend to be on chain. But that's why we focus on these security councils. Basically, our very strict definition of what a good multisig is only made for security councils. So for these specific upgrading multisigs for stage 1 rollups.
But then over this very narrow, looking only at security councils, what are the trade-offs? Like, why do you decide on a higher threshold or lower threshold? I imagine, for instance, that the trade-off that you must have is something about either security and the speed of decision. And in this case, maybe security is more valuable because it's the Security Council. Is this correct, or am I oversimplifying things?
No, this is correct. But for example, we can see here, this turnkey multisig, I'm very sure they are optimizing for liveness. So they want to be able to act very fast in their own organization. For example, they used 5 people in their organization, and they said if any one of them is able to sign a transaction, they should do it. So they put a 1 out of 5 threshold. But this is not the only thing. Security councils, so very specialized multisigs that are made for roll-up upgrades, they need to do very specific things. For example, imagine we have in this proof system here, we have a bug. So the proof system is actually not well implemented. This can happen all the time because proof systems are extremely complicated. So if this proof system now has a problem, this single proposer can submit, so the operator, which is centralized, it's off-chain, we don't care who that is, it can be anyone. This single proposer can suddenly make state commitments that are wrong and are allowed by the proof system because the proof system is broken, right? And now this guy can steal everything from the bridge because the bridge trusts the proof system, trusts Ethereum, and so on. In this case, a security council has completely different obligations. So in this case, the Security Council must be able to act.
I see.
And able to act for a Security Council means that, for example, for this year, this is a 6 out of 8. So we only need 3 people to stop it from acting. If 3 people from this council agree, okay, we won't do anything, we will go on vacation, we will not care if anyone calls us, these 3 agree, then the proof system is broken and the whole rollup is broken. So this proposer, for example, could just pay the 3 people on the Security Council and say, okay, just tell the others you're on vacation. Like, you cannot sign for the next 2 weeks. And then they have successfully bribed and can steal everything in the bridge, which is not what you would think in the beginning when you look at this. Because in the beginning, you think, okay, you definitely need 6 people to steal anything. But in this case, you only need 3 plus 1, which is the proposer.
I see.
It's like a reverse thing, right? It's like there's like an active stealing and the other one's preventing stealing.
Exactly. And that's famously like why the Security Council are so complicated. And it comes down to what you said, Paolo. It comes down just to liveness, because sometimes a Security Council just needs to act. And that's also why Security Councils are problematic. And why we basically allow them in stage 1. Stage 2, we allow them only under very strict limitations. Okay, now let's make it a bit simpler and just say who can steal funds. In stage 0 systems, it's very simple. The operator can steal funds. So anyone, basically, from this that I showed further up, right? These people that service the chain, like the proposer, they can steal funds. If you have a security council, then in stage 0, it happens what we just said. So the operator and the security council minority, which is these 3 people in a 6 out of 8, for example, can steal funds. So they just need to coordinate among them or bribe each other or whatever. In stage 1, only the security council majority can steal funds. So the minority no longer can do it. And in stage 2, no one can steal funds, at least under perfect circumstances. That's why we have these stages, to make it easier. So you can just say, okay, stage 1, I have to trust the security council. Stage 2, I don't need to trust anyone except Ethereum. So this is not the reality many times. We usually have no proof system. We often have no security council, and we often have no proof system, no security council, and data availability. So transactions are posted not to Ethereum, but somewhere else, which is a huge problem and basically makes you vulnerable.
Just to be clear, when you talk about the proof system, is this the contract that's on Ethereum, which is verifying the generated proofs from the L2, or what is the proof system here?
Generally, everything I talk about is always from the perspective of Ethereum. So when I say proof system, the smart contract of Ethereum, if we talk about risk, obviously, if we want to talk about the whole proof system architecture, it doesn't make sense to look only at the verifier contract on Ethereum. We have to look we have to look a lot into the ZK circuits and all this stuff, right? It's super complicated, but it doesn't change much for the risk. You can argue about complexity and bugs and everything like this. But from an architecture viewpoint, the risk only depends on the smart contract on Ethereum, nothing else. So perspective is always Ethereum.
So the proof system is the contract on Ethereum that verifies the zero-knowledge proof. The security council is the multisig contract on Ethereum that everybody signs on. And then the DA layer is the place technically where people store the transaction data on Ethereum, or something that is, okay, I see that's what you're saying.
Yeah, that's also why our perspective is very narrow, but you will probably begin to understand why we are so focused on Ethereum, because everything else becomes super complicated, and it's not like the problem that we wouldn't be able to research it, but the problem is at scale and from a user perspective, if you introduce any other trust assumptions except from Ethereum, especially if those trust assumptions are entire other blockchains, from a user perspective, this is completely impossible. You cannot run like multiple nodes of multiple blockchains just to secure your own funds. You cannot be your own bank anymore if you have to rely on multiple blockchains. So it's all from the user risk perspective, and more complications and bigger dependency set in trust assumptions just means you will not be able to have any transparency as a user and any practical security as a user. This is from a few months ago also, but it's very much stayed the same. On the left, we have the security councils that are currently deployed, and on the right, we have projects without a security council. So there's very few projects actually having a security council. And here the same with proof systems. So on the left, projects with proof systems. On the right, projects without proof systems. I'm not talking about like bad proof systems, but they don't have any proof system.
So what are they doing? What are they posting onto Ethereum then?
They're doing the same thing. They're posting state commits, but the bridge just blindly trusts any state commit by this one single guy. So he could post anything. This is basically one single address being able to steal everything.
When you're saying that there's a proof system, typically for those setups, there will be a prover and then there will be a verifier account mechanics.
Yes, like I'm only talking about the verifier contract on Ethereum from the risk perspective, but a proof system is always comprises of the entire architecture and needs approval. Like it becomes more complicated because of aggregation and all this stuff. But only need to look at the verifier contract on Ethereum.
Also, thank you.
So I don't know if you read about this, but DYDX was a big decentralized exchange which was built on Ethereum as a rollup, ZK rollup. And this is a good example for a product or for the rollup that actually was a true stage 1 rollup and then shut down, which is always very interesting for a stage 1 rollup. And after they shut down, all users could withdraw their funds as you would expect, and no one lost their money, and there was no operator necessary. So there was no one necessary to keep the chain running or do any special authenticated stuff. This is what permissionlessness looks like in practice. So with DYDX, you have a good example. And you can still withdraw your funds if you want right now. I'll just shortly say that proof systems are incredibly complicated. And our old assumption, how we looked at proof systems, which was very, especially fraud proof systems, which was very naive, had to be revised. This is also something Luca published, one of our researchers. We had an assumption that in a fraud proof system, any single honest challenger can protect the entire rollup, and all this with a fixed challenge period. And this original vision is completely revised.